Welcome everyone. So this is our 48th live stream geometry, and I'm doing problems again from the Taiwan team selection test this time. So we had some really nice ones last time. There was this one problem with a rhombus that was really hard, but that was probably my favorite problem. But they always get a lot of problem suggestions from people around the world. So with that, I am going to get started. Let me share my screen. Can everyone see it? So last time I did mostly problems from 2020, and this time I'm doing 2019. So we have a triangle with circumcenter omega, and we draw the AX center and the incenter. So I might just use the incenter X center lemma, because that's often the easiest way to do things. So let's see. So here's the angle bisector. I'll draw one more angle bisector just so I can have the. Actually, you know what? I'm just going to draw the end circle. So we have the end circle of A, B, C, and I is the center of B. And then we could draw this point right here. Whoops, sorry. I'm gonna shrink this a little bit because we need to make room for the X center. So D is the midpoint. Then basically by the in-center X center lemma, we can draw this circle through BI and C. And this point's going to be the X center right there. So we could call that J. I don't know if you guys want me to draw the X circle too. Maybe I'll draw it later if it looks useful. Okay, so T is the reflection of J with respect to BC. So I'm going to have to make a little bit more room here. All right, let me move things around a little bit. Diagram just to make room for point T. I usually prefer acute triangles, so I'll try to make it an acute triangle. Something like that. That looks pretty good. So like a taller triangle. So this is point T. And P is the intersection of BC and AT. Interesting. So this is point P. And then we draw the circumcircle of AIP. And we want to see where it intersects BC. So if it intersects BC at X, oh, whoops, AIP. But X, in this diagram, at least X looks like too close to point C. So maybe like that. And then this would be X right here. And sorry, I think this is blocking it right here. And then there's a point Y, so that IA is equal to IY. So I'm going to use the circle tool. Y is on omega. So do these concur? I think these might concur. Let's see. Oh, no, they don't. Okay. So this point is Y. We want to show that the circumcircle of IXY is tangent to AI. So let me make it look a little nicer. hide this.
Y is on circumscribed circle of ABC.
Oh, whoops, you're right. So I'm going to fix that. So this should not be Y. Y should be this point, I think. Yeah. And let me hide a P, and then I'll close all the algebra. So wait, IA is equal to IY. Yeah, that's correct. So I guess I could draw IY. I don't know if I want to keep the circle, so I'm just going to hide this circle for now, but we'll just have to remember that IA is equal to IY. Or I don't think TX and J are collinear. Hold on, I see some people wrote something in the chat. Yeah, give me just 1 second. Let me try to close this. There we go. So I could try to, I hope you guys don't mind if the circle just overlaps the question. Let's check the chat. Dx and y are collinear. Oh, not anymore. Not anymore. I don't think Tx and J are collinear. Oh, of course, no, T is a reflection of J, but yeah, they're not. Yeah, I'm not sure the best way to show that T is the reflection. It's interesting. So I guess it's probably worth drawing this.
IJ and XY perpendicular?
IJ and XY, they might be. Let's see.
Yeah.
It looks a lot like it. Well, let me draw the perpendicular from Y to AJ. Whoops, sorry. Perpendicular from Y to AJ, see if it's the same line. Oh no, they're not. It's really close, but if you move, yeah, like for example, in that case, they're not. Let's see. Can I draw PJ? Yes. And I wonder, maybe you're wondering if it's tangent to, I think it intersects both of these. Because let's see. There looks like there's an, yeah. So it's not tangent to either of those two. I can leave it if you want, but. So IXY, we want to show that circle's tangent to AI. So that is equivalent, that's equivalent to saying, whoops, what's a good way to, I guess that says that angle A or angle YID is angle,
Are triangles AXP and IXY similar?
IAP and IXY?
AXP.
AXP and IXY. Let's see. IXY looks like closer to being isosceles than AXP, but I'm not sure. Whoops. But yeah, so they're not similar.
Yeah, they are not.
Does PD equal PJ? Doesn't look isosceles to me, but let me check. No, but maybe PJ equals, oh yeah, of course PJ equals PT. That's obvious. So let's see, what's the best way to show, if we want to show the circumcircle by XY's tangent, J must be in place of D. I'm not sure what that means. Sorry, I just got a direct message from someone. You think it's worth drawing the X circle? Is JX perpendicular to BC? Like is X? No, because JX and T weren't collinear. But still, maybe it's worth drawing like the X circle. What do you guys think? Yeah, J is the X center. There's not that much room left on this diagram, but maybe it's worth drawing the X circle. Oops. So let me try to get a good picture. Yeah, it is hard to use that. IA is equal to IY. Well, it means, yeah, actually, I'm not sure how to use it, but let me draw the X circle. I don't know if this is just going to make the diagram harder or not, but I'm going to try it. So, well, I guess what I could do whoops. Yeah, I think I think I need to hide this and then draw the point and then unhide it. There we go. So oh, maybe are these three concurrent right here? I'm not sure. No. So I wonder if those circles are, no, they're not tangent. Hi, Animal. Thanks for joining. So yeah, we have a lot of people on this time. And then another person joining too. Wow. Let's see. So yeah, we have to use, let's see. Too many assignments. It's all right. Well, but yeah, sorry you have so many assignments. So what is your UNI? Oh, sorry. They should have gotten that at university. Let me make this a little bigger. Whoops. Can I label O? Yes. Yeah. There's a lot of information in this question. Basically, I guess OI is perpendicular to AY, right? So, or is that true? Actually, I don't think that's true. Oh yeah, it should be true, right? Yeah.
Is IXY isosceles?
IXY, I would be very surprised, but maybe it is. Maybe you're right.
Okay, so our aim is to prove that AIY is similar to IXY.
Interesting. I didn't realize that, yeah, IXY is isosceles. So we want to show that AIY is similar to IXY. That's really interesting.
Or we can show OI is perpendicular to IX.
Okay. OI is perpendicular to IX. Or IX is parallel to AY. Yeah, they're all the same thing. So yeah, we have PPJ as isosceles. O is the center of the circle through A, B, and C. I wonder if angle YIJ is APJ. Not sure, but maybe. Whoops. They used to always do it as an acute angle, but now I think they changed it, makes it harder. Yeah, I think there's more than 93. Actually, maybe it is the same. Oh yeah, so these angles are the same. Interesting. So YIJ equals APJ. That kind of makes me want to extend PJ because, let's see. So yeah, this might not go anywhere, but I just want to test it out. Oh, are these concurrent here? That would be interesting.
YF are linear. We can use it.
YI and F?
IYF, yeah.
IYF. Okay. Let me just, yeah, there we go.
Or is it?
I think they should be. Let me move it around. Yeah, they're collinear. I don't know the proof yet, but they look collinear. We unhide A. Is JAF isosceles? No.
Can you intersect OI and JT?
Yes. Oh, they meet at that point. Yeah. Let's see.
Yeah, and I think they're gonna be cyclic because of what we found.
Okay. So OI and JT. So this point right here.
Yeah. Now ITGA.
ITG and A. All right. Interesting. ITG and A would be cyclic.
Yeah, because you found TPJ is equal to AIY.
Yeah. Interesting. That makes sense. Sorry. So if we can show OI is perpendicular to IX, does that solve the problem?
Yeah, it solves.
Okay. So yeah, can we show that XI, Y is isosceles? Is that obvious? Let's see. Yeah, there's a lot of pieces of information here. I wonder if OI equals OG. I don't know if that would help much, but kind of looks like it. Oh yeah. So basically G is the reflection of I over O. Does that make sense? Let's think about that. Oh, because
Yeah.
it's obvious, right? Because D is the midpoint of IJ and this is parallel, so yeah. I don't think these concur. That's probably just the diagram, but yeah. Yeah, Serdar's right. It's hard to use that IA is equal to IY. So let's see if we can find a way. I'm just curious what happens if we draw this point. I might delete it in just a second, but are HO and Y collinear? Let me just check before I read the chat. Looks like it. Yeah. Interesting. I'm just going to make it a segment instead of a line. The center of IXY lies on it. Is OH equal to OY? Yeah, I mean, basically, I think HO and Y are collinear. And if that's true, since O is the center of the circle, then we would have OH equals OY. But yeah, I haven't proved yet that H, O, and Y are collinear. So yeah, if that's true, that would give us another way to define point Y. I wonder if Y is the midpoint of IF. HGIY would be a parallelogram. Yes, yeah. Is Y the midpoint of IF? Looks like it. Yeah, it looks like YI equals YF. So yeah, there's like a lot of information here. It's just figuring out how to use it all. A lot of midpoints. I get confused what we've proved and what we haven't, just because there's so much stuff here. Let me try. Draw that. Wonder if there's something special about this point. Are KA and H collinear? This is crazy. There's just so much stuff that just works out. Looks like it. Looks like KA and H are collinear. Interesting. So KX is the perpendicular bisector of IY. Maybe that's just a distraction though. Oh yeah. This would be very hard to find without GeoGebra. Yeah, there's just so much information, right? So we want to show IXY as isosceles. So Does Kx equal IF? $5.03. No. But y is the midpoint of IF. So I don't know if we could use the butterfly theorem. Maybe ky and p are collinear. This would be really funny if that were true. No, very close though. Okay, so what, do we know that H, O, and Y are collinear? I feel like maybe we could start proving that. We could show angle HAY is 90. If we can prove IX is parallel to AY. Yeah, but IX is parallel to AY is equivalent to saying that OI is perpendicular to IX. Yeah, just want to make sure that, yeah, these really are collinear. Oh, it doesn't finish it? Okay. Yeah, we don't know that yet. PJ equals PT. Yes, that's true. Yeah, so that's the thing. Like AIY and PJT are both isosceles, but their base angles are like 180 minus each other. But maybe, like, what if I did this? IG, F, and J are cyclic. Whoops, sorry. GeoGebra is slippery. I just I, G, F, and J are cyclic. Nice. Oh, because T is a reflection of J over BC. So Vanch, if you want, it might be easier to, instead of messaging me directly, message it to the group just so that they can see what I'm responding to. 1 second, I'll be right back, guys. All right, thanks everyone for waiting. Sorry about that. Let's see. So yeah, I guess there's like multiple ways to define point y. So the problem defines point y as ai equals iy. But then we could also define it as you let HA intersect this circle at K, and it's the reflection of I over KX. Or you could define it as the midpoint of IF. Midpoint of IF might be like the simplest way. OD is parallel to TD. Or TJ, I think you mean, right? Yeah. Yeah. So yeah, OD is parallel to TJ, and because of that, O is the midpoint of IG. Let's see. So can we say anything? Maybe we could show HG is parallel to KX. Yeah, we have to use that T is the reflection of J. Sorry. I wonder if we could try to make a similar triangle. For example, we want to show that PTL is similar to those two triangles. Maybe there's something special about point L. So yeah, but I don't know if we can do much with point L. Okay. All right. Let's see. A prime is a reflection of A across BC. Okay, so you think you have a solution. All right, so let me try that. So yeah, maybe I added more than we needed here. So you're reflecting, reflecting A across BC. Got A prime. Just shrinking it a little bit to make room here. May shrink it a tiny bit more. Oops, sorry. There we go. Okay, you're saying AIO is similar to A prime J. And we can prove the similarity using inversion.
We know the angles A prime AJ equals to IAO, and from square BC inversion, we can prove that AA prime times AO equals to AI times AJ.
Okay. I feel like, okay, so we probably don't even need root BC inversion to prove that, right? It's probably just, because if H is the perpendicular from A to BC, we want to show that twice we want to show 2AH, so yeah, I guess, yeah, we could use inversion, but like also, I think it's,
yeah, reflecting A across O and the midpoint of AA prime, then we use another similarity.
Yeah, so
the other way.
Okay. So then once we know, I'll call this, let's say R. So basically ADR would be, or
Can you name the midpoint of AA prime?
yes. So that would be H, right? That would be the, well, we already have an H, but we could call it something else. L is good. So
Actually, square root BC inversion is still needed.
oh, really?
Yeah, now we want to prove that AL times AR equals to AI times AJ.
Yeah. So that's like, we want to show AIL, sorry, we want to show AIL is similar to ARJ, right?
But that's not easy. We need to use that AI times AJ equals to AB times AC, or too much similarity.
Oh yeah, AI times AJ is AB times AC, but the thing is that is, you don't even need inversion to prove that AI times AJ is AB times AC, because basically, like if we label this point here, M, then by symmetry, AM is equal to AC, right? So by power of a point, AB times AM is AI times AJ, right?
Yeah, but it's the same thing. So inversion
same
is
thing.
the same as similarity, multiple similarities.
Yeah, so yeah, it's really the same thing. So yeah, inversion is the same thing. And so then we use ARMO. So once we know that those two triangles are similar, how does that finish the problem?
From the similarity, we deduce that IX is parallel to AY.
IX is parallel to AY. That is that what ARMO says?
No, it's from angle chasing, then we use ARMO.
Okay. Okay, so all those points are collinear. Hold on just 1 second. Okay, so I'm going to start writing it up. Whoops. Let A prime be the reflection of A over BC. And then we want to show that AIO is similar to AA prime J. But we have so yeah, that's easy using inversion. So for now, I'll just say easy to show using inversion. But I'm going to add more detail to this later. So once we show this, then so then you said, I think you said something about point X, right? So
Yeah, then we prove that IX is parallel to AY.
Okay.
We do this as follows. Can you label the midpoint of AY?
Yes. So it's N.
Now, BIX equals to BAY.
AIX is EAY. Say that one more time.
DIX equals to APC.
DIX is ABC.
APC from circle.
Sorry, did you say DIX?
DIX equals to APC.
ABC? Or what's this letter? DIX is ABC or ACB?
APC. It's P.
Oh, P, sorry. I bet.
It's from circle.
Okay.
Then APC equals to A prime PL.
Okay.
And it equals to 90 minus LA prime P.
ALP, right?
Then it equals to AIO. Which is the same as IAN.
AN, right?
Yeah.
All right. DI angle DIX is angle APC, which is
Now Arma tells
okay.
XI equals to XY.
Oops, sorry.
And we are done.
Okay. So then by Armo, Xi is equal to XY.
And this implies that the IY is similar to IXY.
So we have those are similar, and then
And this implies that IXY equals to AIY.
angle Y or
Angle IXY equals to AIY.
and then that implies XY tangent to AI. But okay, let me read through this for just a sec. So, okay, we have angle DIX is APC, which is A prime PL, which is 90 minus ALP. So A prime PL. Wait, so this is an ALP. This is so A prime 90 minus A prime PL is I think LAP.
LA prime P.
LA prime P. Okay. And then that's AIO.
It is 90 minus AIO.
90 minus AIO. Okay. Because, well, which is IAN. How do we get, so wait, LA prime P is equal to AIO. Okay, that's where we use the similarity because AIO is similar to A. Okay. And then, so since DIX equals IAN, then XI is equal to XY. Interesting. So yeah, I'll have to look up this problem here. What is ARMO?
Russian Mathematical Olympiad.
I'm sorry, say one more time.
Russian.
Oh, Russia. Okay. And then, okay. So these, we know those are both isosceles. And do we also know that one of the angles is equal? So I guess angle XIY is XIF.
Well, because we know that IX is parallel to AY, we know that angles are equal.
Okay. So I'll just add that IX is parallel to AY here. Okay. All right, and then I'm going to move on to the next problem. All right, thanks for that solution.
I think you should write it below the angle chasing. Below ARMO. Between the ARMO and angle chasing. Yeah.
Okay.
We use the angle chasing to show that IX is parallel to AY.
So if IX is parallel to AY, okay, all right. So we know IX is parallel to AY, and then if we combine it with this equality, then we get XI is equal to XY. Interesting. All right, thanks. So I will move on to the next problem. Okay, so this one has a pretty short statement. So we have a triangle ABC with point P. Point P is like any point. I guess it doesn't even have to be inside it, but I'm gonna do it inside of it. And then we draw a whole bunch of circumcenters. So Oops. So we draw these 3 circles and then the circumcircle baby C. And okay, so BPC is D is the center, and then CPA is E, and BPA is F, and then O is this center. And T is the intersection of BC with EF. So I'm going to want to extend some things here. Let me make it look a little nicer. Maybe something like that. I'll shrink the diagram a little bit. So that's point T. And we want to show the reflection of O over EF lies on the perpendicular from D to PT. Okay, so we could call that O prime. We want to show that O prime D is perpendicular to PT. It's interesting. So I'm gonna draw just this segment O prime O. It's an interesting problem. This I might as well draw these 3 segments. Oops. Okay, so we want to show that O prime D is perpendicular to PT. This almost looks like orthologic triangles again. So we have O prime D is perpendicular to PT. And then we have OD is perpendicular to BT. And then OO prime is perpendicular. It feels a lot like orthologic triangles to me, kind of. Let's see. PAOO prime is an isosceles trapezoid. Interesting. Because yeah, A and P are reflections. So yeah, PO is AO prime. Maybe that helps us find congruent triangles somehow. I don't know.
Can you label the reflections of BC with respect to EF, line EF?
Yeah. And they pass through T, right? B prime, C
Yeah.
prime. I'm trying to look for similar triangles because we want to show OD is perpendicular. I'm sorry, go on.
O prime is the circumcenter of P, B prime, C prime.
Okay. So I'm going to draw that.
I guess that finished the problem.
Oh, really?
Yeah.
So O is the circumcenter of ABC. So let me see. So, because since O is the circumcenter of ABC, if you reflect everything across EF,
Yeah.
then O prime is the circumcenter of B prime, C prime, P.
Yeah. Now we know that BC, C prime, B prime is an isosceles trapezoid, so it's concyclic. Now we can do radical axis theorem.
Okay. And that means, okay, so did you say AP C prime C? No, AP O prime O, right? That's what you were saying, right?
No, B, C, C prime, B.
Ah, okay.
Yes. Now, if you look at the circles, BC is radical axis of the triangle circle ABC, and BC, B prime, C prime. Also, B prime, C prime is radical axis of P, B prime, C prime, and BC, C prime, B prime. So PT must be the radical axis of P, B prime, C prime, and ABC.
And so it has to be perpendicular to O prime D.
Yes.
Interesting. That's a nice solution. All right, I like it. So yeah, we didn't even really use that PA O prime O as an isosceles trapezoid. Let E prime and C prime be the reflections of B and C over EF. And then by symmetry, I'll just let it overlap the diagram. By symmetry, B prime, C prime passes through T. And BC, C prime, B prime is a cyclic isosceles trapezoid. So we have that. And so D is a so since O is the circumcenter of ABC, by reflecting over EF, over EF, O prime is the circumcenter of P B prime C prime. And then by the radical axis theorem on by the radical axis theorem, PT is the radical axis of those two circles. So I'll just write this out quickly. PBC, P B prime C prime, and BC C prime B prime. We have PT is the radical axis of PBC and PB prime C prime. And so that implies that PT is perpendicular to O prime D. And that solves a problem. Implies the reflection of O over EF lies, yeah, they word it really weird, lies on the perpendicular from D to PT. Okay. See how that came out? Ah, not bad. Yeah, it overlaps the figure a little bit, but oh well. Okay. Nice solution. So I will move on to the next one. Let's see. So